Okay, hello and welcome. My name is Aravindan Padam. So today I'll be presenting assignment 1, which is task 1 classification. So my group members consist of Mohammad Kairan, Kartigeyan, Badani and Aravindan. So now this is the introduction about the task 1. So what the task 1 is, we need to do is design a basic CNN model from scratch. Choose an appropriate number of convolution layer, filter, pooling, start paddling, and then slay the design model. Train the model using the above dataset with appropriate patch, number and set epoch to 50. So next, for next part is the model 2. Same, but we need to use the state of the art pre-trained CNN model. So now let's go to the demonstration. Okay, so this is the first model, which is the CNN model. So first, what we need to do is we need to first you go here setting and notebook setting. Please change it to GPU. So next is just save and then run. Then the drive file will be open. So it will take some time. Before that, let me show you the draft file. If you go to the draft file, you need to save your draft file in Google Colab. If you see here, see my drive. So this is where the dataset is saved. So there's two type of data, which is valid and trained. So valid each has the three different classification, which is tetra pack, pad and can. Tetra pack is consists of photo like this, which is box beverages. Then for the next part is if you go for the pad, it's the bottle beverages. And then for the last part is which is the can, is the canned beverages. This is the image of the canned beverages. So each has its own name. So if you see here, each is classified with numbers. So each image is classified in numbers. So the validation is used for this to validate the accuracy of the CNN model, and then is the training dataset is used to train the CNN model. So now, okay. So after you press this, then you need to connect it to your Google Drive. So then first, this one will indicate the number of dataset on your drive. So this is how many the dataset is. Please do remember that each dataset has its own name. So we need to declare that's very important. So then this is the CNN model. So now what I did is I increased the dense layer to 3, which is sigmoid. So sigmoid is a type of activation filter. So there's many type of activation filters such as value and Nemo. So I chose sigmoid. So there's three dense layers, so there'll be three sigmoid. And this is the summarized CNN model. If you see here, this is the convolution. Max pooling. Max pooling is the filter that only if you see the mathematics behind it, max pooling will only take the highest value of the number. So then this is the size of the kernel, 74 by 74. Then there's 32 pitches in it. So then same for the next, there's density, which is 3 filters. Then next is pre-post input data, where as I said before, there's three classes for the image belonging to three classes and image belonging to three classes. This is the train and valid data set. Then start training the CNN model. So if you see here, this is the first CNN model. This is the time taken for each CNN model. Next is report the outcome. This is how the training and valid training and validation accuracy looks like for the one CNN model only. And this is the training and validation loss. And so next is the accuracy. Train accuracy 100%. The validation accuracy is 78.6.5. So what by mean the 78.665 percentage is the after the model is trained, uh, the validation database mean the image uh, will be go through the CNN model. So what must the CNN model do is it should accurately detect what the image is, either can, tetra pack, or pack. So, but what here it says is it only has the 78%. It's consider not not very good and not can be is in between good and bad. So it's 78%. So if you see the next part is so the next part is the same part. You just need to do the same thing, but the same database is used. But for now, you use the VGG16 as a base. So this is what I said the model 2, where we need to use the state of the art clean train CNN model compared with model 1. Okay. So if you see here, this is the three art trained model. State of the art pre-trained CNN model. So this is what it by me. So this is the same. I use the three sigmoid, and also here also for the CNN model, the same thing. I use the three sigmoid. The next is the same thing. Convolution here is the same coding that I used before this for model one. This is model two, and except I have done this coding. So next the same thing. Pre-purpose the input data, then start the training processes, and then this is the plot figure from the model 2. So if you see here, the validation accuracy is 75%, and the train accuracy is 100%. So means it does train it to 100%, but the validation is much means slightly lower than the model 1. So this is the way to do the Google Colab. So this is just the demonstration. So now we're going to the slide. So this is the summarize of the dense layer. I mean the model. There's two types, which is CNN model 1 and model 2. This is VGG 16. So now this is the input. So before that I said there's three type of input, which is for task 1, and there's two type of file safety. The first validation and train file, which is I saved in the drive. This is the can part, and the pad is the bottle beverages. And then this is the tetra pack, which is the box beverages. So if you see here, this is the model accuracy for the I mean the result for the model 1 and result for the model 2. We see here, based from here, you can see that uh, the waveform for the validation accuracy it stood down, but the losses here is it says a slight gap on it. But we see on the model, it's a sharp. There's a lot of edge, a sharp edge on it. So if you see the difference between this is uh, it, it yeah, for model 1 it takes us slightly less time to go for constant validation accuracy. So it's go from 0.69 something to 0.82 something, that it will go in between that. Then it will be constant, which is on around 0.78. This is training and validation accuracy. So next, this is but here is it takes a lower value, which is around the middle part, so it will be 0.6. So this one will be around the upper part, which is 0.7 something. So if you see here, this has the higher accuracy than the model 1. So conclusion is model 1 has higher accuracy than model 2. And also another thing, if you see on the coding, so model 1 takes less time to reach the epoch 50. See here, each time it only take around the highest uh, time taken is 15519 something. But if you see on the model 2, I mean model 2, yes. So it take much more time to end its execution. So each take around 241 seconds to run the epoch. So what by mean the epoch is how many times the data passes through each time. I mean how many times the model train. So if 50 epochs means 50 times it will run. So same goes the model will run 50 times to train the CNN model. So that's all for me. Thank you.
Hello, good day to Dr. Muhammad Razali bin Tomar and my fellow friends. My name is Barnidharan, son of K. Tamilvindan, and my metric card number is CE200101. So today I'm representing my group, which is Group 7, to present you all about Assignment 1 Task 2, which is detection. So the title that we chose for the assignment is face mask detection. So these are my teammates. So we got Aravindran, Karthikeyan Murugu, and Muhammad Kairan bin Sari. So why we chose face mask detection? So face mask is an essential uh, thing that the community need to put on when they are in public. So this can help to reduce the airborne diseases and many health concerning diseases. So our task or our system should identify whether they are putting on the mask or no in a video or a photo. So our goal is to develop an effective system that can work efficiently and accurately to identify the face mask. So the methodology of this project is we are using YOLO. So YOLO is you only look once framework to create a customized detection model. So YOLO can categorize objects in a single pass through a deep neural network. So for this system, we should create a data set that conclude many data that should be classified as images and train the YOLO model to evaluate the model's object detection in a photo or a video. So that's all from me. Thank you.
Greetings, doctor. My name is Karthikeyan Murugu. My metric number is E200227, and I'm from Group 7. So today I want to explain about our project in terms of conclusion. So first of all, we used YOLO because it is a widely used and effective real-time object detection solution with application in various fields like autonomous driving, image analysis, and surveillance systems. So that we utilize the YOLO framework as a quick and accurate tool for this object detection. And the goal is to develop an efficient system for identifying face mask wearers. And also the project emphasizes the importance of compliance with safety regulation in public areas, leveraging YOLO's effectiveness in detecting face masks. So that's all from me. Thank you.
Hi and Assalamualaikum. My name is Mama Khaira bin Sari. Yeah, and in this video, I'm going to demonstrate for task 2. So the task 2, we are using the Google Colab in order to complete the assignment. So the first thing, the first step we have to, we can see here, we have to import the necessary libraries and also the module. And then after that, we have to mount to our Google Drive, which is this is the code. And then the next step is we have to define the three path, which is training, validation, and also the testing. And the next step is we clone into the YOLO. And after done those steps, we move to the next step, which is we change the directory to the YOLO. And then we start to install the requirement for the YOLO. And after done the installment, we move to the next step, which is we using the we get command in order to install the what we call the dependency for the YOLO 5 version 5. And then after done that, we can start to train, which is we in this case we set the epoch to the 50, and we have to make sure that our location is correct, as you can see here and also here. And after that, after done the training, we can start to do the detection on the test images. So in this case, we are using the 15 images, and as you can see here, this is the result. This is the result that is saved to the runs detect ESP, which is the last location is ESP. And after done the detection on the images, we can display the images by change the location here, the specification here, and then we can see here this is our images that has been displayed. And the last step is we can do the detection on the video. So you can see here at the last the video has been saved into the runs detect and ESP3. So the video is, you can see here, this is the video. So this is the final outcome of the video, which is the step that we have done, which is detection on the video. So I think that's all for the task 2 from our group, which is group 7.